Okay, question 47. So to me, question 47 is a little bit of what I would refer to as an angle chase problem. You don't quite have enough information about the angles that you need, so we're going to have to kind of use the old geometry trick. We've used it a couple weeks ago, so I think it'll sound familiar to you. But this also kind of looks like one from last semester where we had to do a system of equations and do about half a page of algebra. Not real fun, but with law of sines and law of cosines, it is quite a bit easier. Also today, as we move along, anytime you guys see the opportunity to use law of cosines, you're welcome to. Like, it's something that you know, so you don't have to stick to law of sines. Just that all of these questions should be able to be solved with just law of sines. Now, when we do the quiz next time, the formulas will be provided to you, but the law of cosines formulas aren't provided to you. So if you want to use those, I guess you would have to memorize them. Also, somebody asked a good question last class about the flowchart. The flowchart is not provided for you. You need to understand the flowchart. You'll just have the law of sines formula given to you and the area formulas given to you. Okay, so what this one amounts to, and this one looks a lot like 48 that you're going to do later today. I think it's got the same type of trick to it. It wants you to find the distance from each of these fire stations to the fire. So ultimately, how far away is this one? And then how far away is that one? So I'll just label them X and Y. Definitely need different variables. So they don't phrase it this way, but this is kind of a, this could be a real life question. Which fire station is closer to the fire is the one that probably should respond to it. So knowing how far away they are, knowing a couple bearings, they can measure those years before the fire was created. Those are not hard things to obtain. Okay, so if I just jump into law of sines, if I want to find a side length like x, I have to divide it by the sine of the opposite angle. And I don't know the opposite angle, but that's a pretty easy one to find, because if this is 80 and that's 65, this would have to be 15. Then you have to set it equal to a side length you know, divided by the sine of its opposite angle. So I could set it equal to y over the sine of this angle. The problem with that is I don't know y and I don't know this angle. So I don't want to have three variables I'm never going to be able to solve. My equation needs to have one variable. Or I could set it equal to this side length over its opposite angle. And, well, right now I don't know what it is, but I see that if I knew it, I could find that side length. So it gives me kind of a goal here. So I need to know a little bit more about these angles. I know this is 15, this is 70 in here. I don't know how big this is. I'm very, very limited. But this trick, again, that's come up on 48, and we saw this a couple weeks ago. When you need more angles, especially if it's bearings, these two lines are north lines, so they will be parallel. And the nice thing about parallel lines is we have all of those angle relationships. So I'm not even going to tell you which one you have to use, but you either need to see alternate interior angles are the same, you need to see that same side interior angles are supplementary, or you should see that corresponding angles are the same. It doesn't matter, but you need to get at least one of those. You got to get some more information going over here. So let's say I only got alternate interior angles. That's the one I usually look for. In just a 10-second geometry review, it's interior because it's inside the two parallel lines, and they alternate because this one's in the top left, this one's in the bottom right. So top left, bottom right is the alternate part. Interior is because it's inside the two, and they're the same size if the lines are parallel. But once I figured out this is 80, these two make half a circle, so this one had to be 100 if I didn't get it some other way. And then these two make half a circle, so if this is 100, this has to be 80. Or you can know vertical angles are the same size. You've got lots and lots of options, but you've got to get something, you got to get some other angle over here. So my recommendation is alternate interior angles. Okay, now I could look at this triangle and say, okay, I know 2 of 3 here. So I'll just subtract the 2 I know from 180, and this would tell me this angle has to be 30. And then that's the last piece I needed to find sine x. X will be 30 times the sine of 15 divided by the sine of 30. Make sure your calculator is in degree mode. Everything we're doing with law of sines and law of cosines is degrees. Okay, and it wants to know y, so I guess I'm pretty close to this one. So I kind of approach it the same way. Law of sine says y over the sine of y should be this angle, which I don't know yet, is equal to any other side length, like maybe the 30, over the sine of its opposite angle. So right now I have 2 unknowns, but if I do a little more work to figure out this angle, then I can just solve and throw it in the calculator. So to me, this is very much what they call an angle chase problem. The work's not hard, but finding all the angles you need is where I spend my time. For this one, I would probably look at this great big triangle to find this angle. It's probably not the only way, but I've got a 15 degree, a 30 degree, and then this one. So all 3 of those have to add up to 180 because it's a triangle, which tells me this whole thing is 135. Now, I don't really care that this much is 70. I didn't even really use that at all. I didn't need it. But all of this is 135. So the other distance from the fire tower is going to be 30 times the sine of 135 degrees divided by the sine of 30 degrees. Let the calculator do the arithmetic. 42.426, and we should put units, kilometers. Okay, is that enough there? Okay, so I suspect other people were going to ask about this one, so please, if that didn't get you unstuck, you need to speak up and let me focus in on where you're having issues. Any other questions on that one?